Ladies and gentlemen, good evening. Tonight we're going to talk about Jdbc. What is it and what is the difference between the different types that we have? Let us get right into it. First of all, Jdbc stands for Java Database Connectivity, and it is actually the API that connects our Java applications with databases. So that means that when I have my Java application, if I want to execute something or get some data from a database, then I can do it through a Jdbc driver, as long as I have that included into my project. This Jdbc driver, it is specific to which kind of database that you have. Here you can see that we have the Java application, then we have an API that we can connect to, then we have something called the driver manager. The driver manager handles the connections to the databases, and we can also the instances of the Jdbc drivers. And the driver manager can actually handle multiple connections to different databases at the same time. So that is the purpose of the driver manager. And as you can see right here, it's a good way to actually separate logic and to separate our code from what kind of database that we are actually using, because we can use a Postgres database, we can use a MySQL database, a SQL Server, Oracle. Does not matter what kind of database we are dealing with. There's a driver, there's a vendor-specific driver per database. And usually, of course, these vendors, they are very interested in us using their database. So, of course, they also supply these and maintain these Jdbc drivers for their database. There are 4 types of Jdbc drivers, and let us just go to type 1. First of all, the type 1 is also called the Jdbc ODBC bridge. That means that you need to have an ODBC driver installed on your local machine, and you can also place your credentials there. That is the benefit with that actually. And then the ODBC driver connects and uses a database vendor driver, and then again that then can connect and talk to a database on a remote server, or of course also on a local server. This is called type 1. It is used very rarely these days. The only type is actually type 4 that is used these days, mostly, in my experience at least. Leave me a comment if you think I'm wrong with this. Then we have type 2. This is called the Jdbc native API, and here we have some code that then uses Jdbc type 2, and it uses a native API that could be C++ on the machine where it runs, and then it can connect and talk to the vendor driver, which also needs to be installed on your client machine, and then that again can then connect to the remote or local database wherever it is located. Then we have type 3, Jdbc Net. Here you actually set up a middleware server. That means that you will set up a server where you will install all of these different types of Jdbc drivers. Maybe you will have a type 1 and type 2 or type 4. And then these Jdbc drivers can then connect to a database. So that means that if we choose type 3, then that means we are from our Java program. Then we have some code. It uses the type 3 Jdbc driver, and then it connects to the middleware server and uses the Jdbc driver, which are installed right there. And again, this can be type 1, it can be type 2, or it can be type 4. This is, I think in the old days, this was actually quite popular. Then we have type 4, pure Java, and this is what I see. This is the most common, actually, at least in my experience. And this is where we actually have the Jdbc driver as a pure Java driver, and it's actually included as a dependency to your Java program. And then it means that then you can actually communicate from your code to that type 4 Jdbc driver, and then you can connect to the database. It's also the most simple setup. You can see there's not that many boxes in this scenario right here. So it's very simple, and you have the Jdbc vendor-specific driver included into your project, into your Java project. So it is type 4 that we usually use, and I have a code example so we can see how it actually works. Because when we're dealing with a Jdbc driver, first of all, we need to add it as a dependency. If you're using Gradle, then you would then it would look something like this right here. Implementation, and then the name of the JDBC driver. In this situation right here, we have a Postgres, and it's the version right now is 42, 2, and 23. So, and if, of course, if you have a pump.xml file, it would just look a little bit different. It would just be XML instead, and then you will still have this dependency right here. Then I have a very simple Java program right here. Okay, before we continue, it is you probably won't have a database installed already at some server that is just ready to use, and I would recommend that you use Docker, because then you can easily spin up a Postgres, for instance, or another type of database by using Docker Compose, for instance. And I've created a Docker Compose.yml file right here. I'm defining my services right here. I'm just using version 3.1. There's not a lot of thought behind this version right here. It could be a lot of other versions instead. Then I have named a service my Postgres server right here. Then I have the image, which is Postgres latest, and you can go to Docker Hub. That's what I want to say, Docker Hub, and then you can read about how to use this image right here. And it will also give you some good advice of which settings and which environment variables you can set in order to tweak your Postgres database. Restart always. That means then it will restart always. Yes, and then we have some environment variables right here. Those are important. I've set the username, the root username to Mike, the root password to ABCD1234. Of course, you would never do this in a production environment. This is just for development. Then I've created a default database called Mike's DB, and then I have set it on a network called DB network. If you want to, you can just use a default network. Then you can just leave out this section right here, and you can also leave this section down here in the admin image. Then I'm mapping out the port 5432, and that is because that is the default Postgres port. Then I can connect to localhost and then this port whenever I want to connect to my database. I have this. I would definitely recommend that you also spin up an adminer, a container based on the adminer image. This image right here enables and gives you a UI, a web-based UI, where you can connect to MySQL, Postgres, and also some other databases. It is awesome for giving yourself a view into other databases, into databases. In this situation, you need to map out the port 8080 because that is the port that it runs on inside the container. And again, when I map it like this, that means that I can go to localhost port 8080, and then I can access the web-based UI. Here I'm defining my networks, and I'm creating a new network, DB network. It's actually not necessary per default. These Docker services right here, they will be a part of the default network if you don't write anything. If you write this like this, then they're not part of the default network. But when they are on the same network, then they can actually see each other by using the service name. That means that if I'm inside the adminer container, then I can actually see my Postgres database with the name my Postgres. There's actually a host file that will be updated automatically when you spin them up like this. This is one of the many good things about Docker Compose. So let us get started. Let us spin these up so we actually have a database and also an administration interface. I do that by writing Docker Compose up. And I've actually already started them up just some time ago, and this means that I did not have to download all of the image snapshots, and that's why it started up so fast. You would have to wait for Docker to actually download these images here. As you can see right here, I have one line here, admin 1 right here, that says that the port it has been started on port 8080. And I also have some my Postgres output right here, and this _1. This is just because we only have one instance, and then Docker Compose is naming these containers, giving these containers names automatically, and then it just got _1. And here we can see that the database system is ready to accept some connections. And I've cheated a little bit, and I've already added some data. I've already added some data, but I'm going to delete it all again as one of the first things. Localhost 8080. And then first of all, I need to choose the database. You can see here I can also use SQL Server, Oracle, or Elasticsearch. SQLite, but now we want to connect to a Postgres database. And here we need the service name, and that was, what did I call it actually? I just forgot. I named it my Postgres, so let us go to my Postgres like this. Username was Mike, the password is ABC, D, 1, 2, 3, 4. The database is Mike's DB like this. And yeah, let us just leave it as a permanent login. I should not have to log in again afterwards. And here we can see I already have a table named Spaceship. And inside there, I have some data. I already have 3 rows right there. And the first thing I'm going to do in my Java program is actually to delete all the data. But let us just for fun, let us go to the database right there, and let me drop the whole table right there. So now I'm dropping so now we don't have any tables or views in our database. Let us go back to the code and let us focus on the code now. Because what are we going to do here? This is a public static void main, so it's just a main Java main program. The first thing we need to do is always to load the driver. We need to initialize the driver, and that is done with this line right here. Class.forName, and then the name of the driver that we want to load. And this, of course, you can see right here. This is a class. Here we have the package, and here we have the name. If you're using another database than Postgres, then of course your driver would also be different than this, right? So, and of course, you can also load and initialize more than one driver. And then we set up something called a connection URL. So this is our connection URL. We start with saying that this is a Jdbc. That we want to use the Jdbc protocol, and we're using PostgreSQL, the Postgres server, the Postgres database. That's what we say with this line right here, with this part right here. And here comes first comes the server that we want to connect to. That is localhost. The port that we want to connect to, and then the name of the database where we want to be located by default. Of course, we can change the database location on afterwards if you want to, and if you have the rights, if you have the correct rights. But I want to be placed in this database. That means that when for instance, when I'm creating a new table, then it will be inside the Mike's DB per default. I don't need to mention the database all the time. Here we have the connection. I'm creating the connection through the driver manager. Get connection, and then the connection URL, and then some credentials, the username and the password, like this, Mike ABCD 1, 2, 3, 4. And then I've created some methods. Let us go through these methods, because that is where the magic happens. First of all, we need to create a statement in order to give our database commands, and also to retrieve data from the database. So the statements, that is where we are actually executing the SQL. Then we need to create SQL structure query language, and that is the database language. So that means that, and this is specific per database type. So if you create a great SQL for Postgres, it might not work with MySQL, because the syntax it varies from database to database. That is why JPA is so cool and awesome, and also something called Hibernate is very cool and awesome. We will not go into that today. I'm just giving you those buzzwords, then you can look them up yourself. And of course, I will also create other videos about those topics. I already have, actually, if you look at my Spring Data videos. So, okay, then we have then I'm just printing out the SQL. Then I'm executing the SQL. If any errors, if we get any exception, if we get any errors from the database, then those are being thrown with the throws SQL exception signature on our method that we have right here. And as you can see right here, all my methods are just static. Of course, it should not be that. We should try to avoid static methods, but I'm just doing this for just for this demo, so we can see how it actually works. Then we are deleting all rows, and as you actually can see right here, I am reusing the connection. So I'm instantiating, I'm creating a new connection right here, and I'm reusing the connection for all of these operations right here, and then I close the connection in the end. And that is, it is good practice not to close and open connections all the time. Usually you would keep one connection open per request that you get to your backend. So if you're creating a backend, then you would keep the connection open for the for the time of until you have actually given a response to whichever client connected you back to your backend. Because there's an overhead with creating a new connection. It also there's also usually a limit for how many connections the database accepts to be open at the same time. Sometimes you would also use something called connection pools, where you will take a connection from a pool and then you would return that connection to the pool when you're done using it. Okay, so that was create table if not exists. Let us just, we saw right here, create table if not exists, spaceship. So here we're creating a spaceship table. It needs to have an ID. It's always good to have something unique on your tables. So an ID on each table is best practice. And right now it's actually not auto generated. You could also set it up so the database will actually generate that ID, and it will just take the next integer, next available integer, and add one. And then we have the captain right here. That is of the type varchar 14. That is so I can actually force out an exception. If I invent a captain that has more than 14 characters, then we will get an SQL exception, and then we can see how that looks. Then we have fuel, which is an integer. The whole number is percentage for how much fuel is left on the spaceship, and then we have a shape of the spaceship right here. So that is how we create the table if it does not exist. Then we have delete all rows. I added that because then I could delete all of the existing rows from my spaceship, and it just does what it does. It deletes everything from the spaceship table there. Then I have insert row, and here I have chosen to actually extract the SQL and actually write the SQL as an argument, as a parameter to the method, because then I can create more of these. I can create more of these. If I press Control D here for duplicate, then I can insert one, and then again I need to give an ID, and then we have a name right here, Susan, 10% fuel. Then we can have a pyramid instead right here. And then in the end, I am selecting the ships, and this is a little bit different because here we actually we get a result set. We get a result set right here. And you can see statement instead of just execute, then we use the execute query method because we need something back. And here we get the result set, and then you can use this while sentence right here, this while syntax right here to just go through each row in the result set. And I do that by placing this. This will place the cursor to the next row every time I do that. So the first time I call this, then the cursor will be set to the first row, and then I can get each field, each piece of data, each field value by using the name. Then I can say get string, and then I can say get the captain, get int, then the fuel, the shape, etc. And then I can print out all of this data that I found. And I can do that for each row that that is right there. In this situation, I'm catching the SQL exception. I could also have added it as a method signature, but in this situation right here, I am catching it just for fun. And that's actually it. Let us run this program and see what happens. Run. Connect to database. And we can first, let us see the run first. Yes, look what happened here. We are printing out the SQLs, and we say we found a row, Mike and Susan, and then now let us go to the admin. And here we can see now we have the table that has been created again. And here we have the data, Mike, Susan. Cool. Then the next thing I would like to do, okay, we went a bit fast. You can see it's right there. The next thing we want to do, we want to provoke an exception to happen. So instead of Mike, then I'll just write something that's more than 14 characters long. And now we should actually see how the SQL exception will look like. Another thing, I'm catching the class not found exception. That is, if this driver was not, if the Postgres driver is not available, then we will actually end up as a class not found exception. Then we will end up down here. So that means that then it's probably because we forgot to add the Postgres Jdbc driver to our dependencies. Yeah. Let us try this. This should actually end up in an SQL exception. Let's see what happens. Now, so we got an exception right here. Error value too long, type character varying 14. That is because, and of course now I taking up the space, I'll just press right down. Takes up, so that means that now the cat is has a name that is too long for the database, and then it complains with an SQL exception. Of course, we can just fix it. We can fix it two ways. One way is to change the definition so it accepts a longer name, or we can just we can go back to our original captain like that, and then it's solved. Thank you very much for watching. I hope to see you again soon. Have a great evening. Bye bye.